My name is Simson Garfinkel, and I'm going to tell you a bit about a program I've been working on for the past 6 months. The project is to take medical records and store them on optical discs like this one. And outside of the picture there's an optical disk drive, which I'll show you in a bit. The discs are a by-patient archive, which means that you have one disc per patient, although the system is easily modifiable to have multiple patients on the one disc. Most of the system is driven by this mouse, and it runs on a standard IBM PCAT with a main screen, which we have in color, and a screen for the medical images. This is a 1280 pixel by 1024 pixel display, 8 bits per pixel. It's manufactured by a company named Number 9 Systems, which is in Cambridge. The computer is a 386 made by Compaq. It could just as easily be a 286. The speed of the program is achieved through careful coding and through special function hardware on the Number 9 board. When the disk is first inserted, the user gets a choice of 7 menu options. They can view the studies on the disk by modality, by date at which they've been entered, or they can simply view the most recent one. Other options here are for copying all the studies, copying some of the studies, or duplicating a card. Notice that when I move on to the buttons with the mouse, they light up. We view by modality. We get a list of the 10 modalities that the card can support. This is the CAT scan, nuclear medicine, magnetic resonance imaging, digital subtractive angiography, and ultrasound are known about by the system, but there are none of those studies on this card, and so those images do not light up. We also have digital radiography. Chemistry and text are for images that have been scanned in, and all will simply give you all of the images on the disk. Here's CT for the CAT scans. We see that there are 2 CT images on the disk. There's a big study of 7 frames, and there's a baseline study of 3 frames. It displays the most recent study first, and it displays a little icon that consists of the picture, the first image in that study. You select on things by clicking on them with the left mouse button. The right mouse button is used for a magnifying glass, which I can display here. And those are the only 2 mouse buttons used. It's a 2-button mouse. Here's the main screen. It gave us the first 4 images in the study. There's a circle here that's been drawn. That indicates this is a region of interest. At any time, the doctor can pick an icon from here and display it in any one of the quadrants. And it works like that. These images are coming off of the optical disc, and the transfer rate is approximately 300 kilobytes per second. If you want to just click on an image, it will display a sequence of them, the current image and all the next ones. You can grab an image and move it like that to make room, or you can have them delete. Now if I'm interested about one of these images, I want to compare it with an image in another study, I can put it into this holding area, and then I can pop to the previous directory, click on the baseline study, and I can compare. You'll notice that these icons down here behave in the same way as these icons here. The upper left area is for images in this study, and the lower left area is for images that have been held. If I'm done with them, I can click on that and clear. The top row of buttons are radio buttons that control what's in this region, like push buttons on an automobile radio. This selects the holding area, that's something in the holding area. The second button selects the contrast control, and we can adjust the max and the min. They're sliders that can simply be moved up and down. If we get a contrast that we like, we could say OK. Adjust the holding area, the contrast again, and I can put it back the way it was. And that probably looks a little bit better to you. Now, remember there was a The other control of interest, this is for drawing new circles and so forth. And I can place a circle here, and I might want to place a square here. Now these pictures are drawn, these circles are drawn as white surrounded by black, so they'll show up no matter what they go on. I can zoom in this button here, and as I indicated before, there's also a magnifying glass or a loupe, which can move any part of the region. Actually, any part of the area. Clicking it again gives us a higher magnification, and clicking it a third time gives a higher magnification, still clearly seen pixels. Click it a fourth time and it turns off. The zoom button turns to unzoom button, and I can click on that now and give me the original image back. It even redrew the regions of interest. Now these will automatically be saved on the optical disc when I click onto another picture. And save time to update anything on the disc. On the right-hand screen is a report bit. There's a summary, and then there's the textual report that can get on a picture. With every image, there is also image information, the name of the referring physician, or comments. You can look at the experimental parameters, such as the kilovolts that the X-ray tube was on, the identification number. These are not filled in this implementation, but if you want to come up with it, you can simply click the form and say total dose is 32 rads. Obviously, this patient, and that's being updated on the card. So I dropped out of that form. Patient's name, insurance plan, and other comments. All comments can jump back and fast pretty quickly. Now, of course, there are other modalities. On the previous direction. These were all system with a. Take that back. These were all transferred to the system on a disk. The files were in the Gamma 11 file format, which is an industry standard. One of the first uses we're anticipating for this system is archiving nuclear medicine. So let me use the contrast control to bring them up a bit. You can see the kidneys, and in these successive time frame images, you can see that the amount of tracer is increasing in the low region of the scan. It'd be nice to be able to sequence through them like a movie, and you can do that by clicking on movie. If I click, it will begin scanning at about half a frame per second. Fast will do it at about a tenth of, well, about 5 frames per second. Faster is the fastest, and that's 32 frames per second. It's actually doing block copies from different frames. And you can see here that the tracer is increasing at the bottom. You can stop that, and you can single step it forwards or backwards. If you want to just scan, you can say range, and say scan from this one to this one, and do that in the movie. And it's just going from 1 to 8 now. We're done. Exit out. Also, if I'm here to the form and edited anything you want, the actions are, we want to do magnetic resonance scans on this. If it wants to see a black bone study instead of a white bone study, they can convert. It's pretty fast. There's some other features. One of the nice things about this is you can quick. It's crazy. Okay. Notice it didn't work, and that's intentional. We want doctors to be able to use this by the mouse keyboard. The mouse might be broken, or keyboard. Hit a button and get the image directory. Hit another, get that deeper directory, and typing an image number or a study number at any time will pull up that image or that study. There are a few other buttons on the keyboard. There's a privacy button, which you can press at any time, which will blank both screens. Pressing space restores both screens. That's very fast, and it's also very important in case somebody walks into the room who you don't want to see what's on the screen. there's a print button for printing out these reports. You get a list of whether you want to print the report only, the selected image only, the report and the selected image, or the report and all the images in the study. That moves up and down. If you want to print an image, you can print just a common field, or you can print all the fields. And then you can choose whether you want to print the current version only, the current version and all the changes that led up to it, or the first original version only. And this is because we are using a write-once optical disc. We're actually using a file system, which I developed for this project. And the file system, in addition to allowing you to easily access all of the regions of text and fields, also is redundantly storing information on it. That means that every file header, every text block is stored twice. Mutilated, that won't be a problem in most cases. It's interesting to note that during the early part of this development, from November, we were using a floppy disk, a optical disk controller that was failing on 1 out of every 3 runs. Notice this because the file system's redundancy was accounting for that, and we can abort that by pressing escape. Other keys select whether you want to see the report, the image information, the acquisition information, and the patient ID. Now most of these forms are locked. You can't press the key and accidentally damage the information on the form unless you first press the edit key and there's an edit. Some users there will be a password system where a nurse will insert their password. Also a provision to undo any edits to a field if you make a mistake. Most of these things can be exited just by pressing escape. We also have an integrated help system. At any time you can press the help key and get help specific to that part of the program. So that's the bulk of the system, and thank you for the time that you've given me. Hi. My name is Simson Garfinkel. I'm a consultant here at Polaroid Research Labs, and for the next 10 minutes or so, I'm going to tell you about a project that I've been working on for the past 7 months. The project is to build an application program that uses optical recording technology to store medical information on optical discs or optical cards, such as this one. It's part of the IRIS project. The idea is to store information on the card by patient, and the system is a compact 386S running at 16 megahertz. Now it is a 386, but we're using it in 286 mode, and if you just easily VCAT, Laser Magnetic Storage International, write-once optical disk drive, a color screen, and a black and white screen, which has 1280 dots across, 1024 dots down. It's being driven by manufactured by Number 9 Systems, a small company in Cambridge. When the card is first inserted and the system is turned on, you, a physician, or you, the operator, given a choice of actions. These are buttons on the screen. The buttons light up when the mouse moves on top of them. You can view the images that are on the card by modality. You can view them by date, or you can view the most recent images first. Images on the card are grouped into studies, and we can view by modality. And, when you click on View by Modality, you are given a list of all the different modalities that might be on the card. Ones that are in black are card modalities that are present on the card. Ones that are gray are modalities which the system knows about, but which aren't present on this particular card. The decision was made early on in the design of the system not to have things moving around and changing very rapidly or from session to session on the screen. We try to keep things as consistent as possible. Clicking on on CT lets you view the CT or CAT scan studies that are on the disc. And we're told that there are 2 CAT scan studies. They're presented most recent first. This one has 7 frames in it. This one has 3 frames in it. Now these selections are being made with a mouse. The left-hand button of the mouse always picks. The system brings up this main view screen. We have the first 4 images in the study given to us on the screen. These are 512 by 512 images. And we're given here icon representation of all the other images that are in the study. If we want to look at this icon, if we want to see it here, we can pick it with the mouse and move it there. And that transfer time is directly off the optical disc. If we want to see this image here, we can grab it and move it there. If we only want to put this image here, we can grab it and do that. Now notice that this image here has a circle on it. That's a region of interest. If we're very interested in that region of interest, I can use the right mouse button and bring up the magnifying glass. Clicking a second time triples the magnification, and another time is 4x. We can look around at different images on the screen with this high magnification or low magnification. Or if we are really interested in this image, we can zoom and make it fill the screen. Click on zoom out and it repaints the screen. Again, this transfers directly from the optical disc. Now, this here is a holding area. If we're particularly interested in a few of these images, we want to compare them with similar images in another study, we can grab a few of them. And they're in the holding area, top to a previous study. And compare them side by side. And here you have those annotations again. These are regions of interest, and they can be drawn by clicking on this region of interest button. Now before I do that, I should explain that this is where icons for the current study are. This is where icons for the L study, any icons that you might hold are. And this area is variable. You can change what's displaying there by clicking on one of these radio buttons, and I call them radio buttons because they work like buttons on your AM radio in the car. You click on one and you hear that station. You click on another, you hear another station. I can click on the contrast control and change the contrast. And these are 2 sliders. One controls D-min and the other controls D-max. I can reset that. On the ROI radio button, I can then say, in this image, erase the regions of interest that are annotated. Draw them. I can even say, let me draw some new ones. Let me put a circle here. And let me put another rectangle there. And if it's getting too complicated, I can just merge it all. And when I exit, or start looking at another picture, those changes will automatically be written to the optical disc. The fact that I've deleted those regions of interest. And let's put a line here. Now when I look at another image that writes it to the disk, this is the right time. On the right-hand screen at the same time is a listing. And on the right-hand screen is a report of the particular study that we're looking at on the screen. The report can be up to 8 pages long and consists of a summary, which was displayed on the directory, and text. And again, that's up to 8 pages. For every image, we also store image identification information, such as the name of the procedure, the study time, the modality, the referring physician, the attending physician, and again, comments up to 8 pages. We also store acquisition information, when the study was acquired, the total dose that the person received, the thickness of each slice, or the software version of the program. There's also patient information that's stored on the card, the name and address of the patient, and again, comments up to 8 pages long. If we're looking at image identification info, this is for image 5. We want to see image 2, just click on it, and now it's image 2. And that is transfer time from the optical disc. Now, of course, you might want to look at other images. The beauty of this system is it's a general modality system. We can look at CAT scans or nuclear medicine, resonance imaging. I happen to have some nuclear medicine here. I have a renal scan. These were originally acquired on a 128 square camera, and we magnified them to 256 square to display them. That's done automatically when they're scanned in. These images were brought into the system with a Gamma 11 file format on an IBM PC floppy disk. It's a little hard to see the kidneys. You can use the contrast control to bring down the max until it's really bright. Now these are all time images, and one of the features of the system is that we can animate them by clicking on the movie button. We have a picture here, and we can step through fast, which is about 5 frames per second, or faster, which is about 32 frames per second. Or we can go slow, or slower. You can stop it and step forward one at a time. Now if you just want to see the range of 8 of these, you can do that by clicking on the range button. Select the first one in the range and the second one in the range. And now when we run it, it's just stepping from 1 to 8. You probably can't even see that. It's not really useful here, but I haven't shown it to you yet. If I want to say I'm done with the movie, you put the color map back. There's a flip button that will flip the background. That's pretty fast. I guess it makes more sense with another modality when we show you X-ray happens. A few chest scans. So I might want to see things black bone, or I might want to see things white bone. That's easy to do. And again, I can always adjust the contrast. It's a really fun thing to do, just see the positions when they come in here. Now, I've been doing all this by the mouse. I haven't really touched the keyboard once, but this whole system can be keyboard driven, which is kind of nice in case the mouse is broken, or in case you have a physician who really doesn't like using the mouse. Image directory button, and then I can pick which modality I want to see, say all the MRIs. All these images have little numbers in the corner. It's image 27, it's image 47, and I can look at it just by typing its number. And a window popped up for me to enter that number in when I started typing. I'm looking at image 23. If I want to look at image 26, I can simply tell it to go to 26. Go to 26 there, block out the rest. It's not as powerful as using the mouse, but it's not a mouse. If at any time somebody walks up and I don't want them to see what I'm doing, I can hit the privacy button, which blanks both screens. That's important. In case somebody walks in the room, I don't want them to see what you're doing. I can hit the print button and be given the option of printing any of the textual information. I can print only the report, or I can print only the information about the selected image, or the report and the selected image, or the report and all the images in the study. Select that with the arrow keys and return. If I'm printing an image, I can print just the comments, or I can print all those other pages of the image identification information and the image acquisition information. And I can also print only the current version. I can print all the versions of all the comments, or I can print only the original version as typed when it was entered into the system. We can do that because we're using a write-once optical disk, and you can't make changes to something that's stored on a write-once optical disk. We can just store new PowerPoints. This is using a file system that I wrote called the Simple File System, or SFS. It also has the advantage that it stores all information on the disk redundantly, usually on opposite sides of the disk. This means that if the disk is damaged with a pinhole or a scratch, you can usually get back the data. Now, the file system is also redundant in operation. Things fail, it retries, both on reads and writes. And an interesting note is that from November until approximately January of this year, I was using a faulty controller that was writing bogus information to the disk, approximately 1 out of every 3 or 4 writes. I didn't detect this for 3 months because the file system was discovering that and simply rereading other copies or trying to make do with invalid information. I didn't even notice it. Let's not print anything. Let's see, that's really much it. We also have the ability to copy information from one optical disc to another. We can make duplicates of a disc, or we can take studies that have been held and save them out for new studies. I want to thank you very much for the time you've given me, and this is the IRIS Medical Card Application Program.